introduce Jared Hill, the Director of SportEng, a national business that specialises in planning, design and construction and inspection of fields of play for all sports. Jared is also a Vic Tas Regional Board member who I sit with at times, and also sits on the research committee for Vic Tas PLA. So without any further ado, I'll pass over to you, Jared.
Thanks, Grant and Rich, and thank you for the opportunity to talk to you all and taking the time out of your morning to have a listen to this chat. As Richard said, I like to think of it as an informal conversation at the end of it. I'm hopefully only going to talk for about half an hour, and then to share some thoughts and experiences that we've had in the past couple of years in particular around this topic, and then really just it'd be great to get some feedback from the greater group on their experiences as well. So without further ado, I'll dive into the conversation. The topic I chose today to talk about was preparing to reach net zero carbon emissions by 2050, and that's something a lot of countries around the world are aiming for, and a lot of our states around Australia have actually taken that on board along with the councils. I like to come back to this very basic diagram of the carbon cycle. There's probably much more qualified people to talk to you through the basis of it, but I guess the thing that always stares at me right in the face is the amount of more arrows heading up into the atmosphere than those heading down. So really is a true representation of there are much more points of carbon dioxide creation, and obviously the one on the left being the burning fossil fuels being the largest, and there's only a few ways that we can actually offset some of that carbon through the absorption through the trees and the earth, and the exchange that the water has in the oceans. So it really just gives you a bit of a basis of where a lot of the cycle starts and finishes. So what is CO2? So carbon itself is literally found everywhere. It's in our air, food, products, and even ourselves. It's essential to the survival of plants and animals, but like everything, too much of a good thing is too much. So obviously that's something that's impacting some of our plants, flora and fauna. It's a greenhouse gas, and CO2 is the leading greenhouse gas emission produced by human activities. As you can see, the annual global CO2 emissions has exceeded through the times. Obviously, the industrial age has significantly increased that. So it really just shows the future we're looking if that graph continues to rise at the rate that it has been over the years. Like I said before, excessive CO2 emissions is not good for much. It sits in our atmosphere and it creates an overheating of the planet, so the heat gets trapped in, and obviously whether you buy into the global warming or not, the figures do show that there has been an increase of temperature as a result of the CO2. So really just talking now about what we do in regards to our products and our services and everything we look at. Historically, we look at what is commonly referred to as a cradle to grave linear system. So we take, we make, and we waste. So everything when you walk into Kmart, into Target, everything on the shelves there is all a cradle to grave. There's no repurposing, no recycling, no nothing. A lot of that cheap product ends up being taken from the earth, manufactured, and then thrown to waste. So that's the model we've historically worked to, and now what we're looking at is trying to move away from that system. I said the Paris Agreement, it was in 2015, 197 countries came together and agreed upon the United Nations Framework Convention on Climate Change. So the overall emphasis of that conversation was around doing better and doing good for the environment, with the intention of coming back every 5 years to agree on what that will be. And a lot of it, they all came together again in 2020 last year, and a lot of the flavour has been around the need to target net zero carbon by 2050. So most of the countries have set that as an ambitious target. Some of them have set intermediate ones. At 2030 is a common one where they're trying to get at least half of that savings in that period of time. So it is something that a lot of the countries have agreed to. It's a legally binding treaty, and whether, as we've seen, not that it doesn't always mean anything. It can be, countries can move out of it, but it's really the first time in a long time a lot of the countries have come to the same table and agree on an action towards climate change. So eco-efficiency is a term and a phrase that was used in the last handful of years around being more efficient in what we do, using fewer you're using fewer natural resources for production to obtain the same outcome. So really getting the most out of what we're working with, and generating less waste. We'll be all familiar with the 3 R's: reduce, reuse, and recycle. What we're trying to do is move away from that as the only point of call of what we can do. Reduce doesn't actually stop the damage; it just slows it down. So we are more efficient in our power consumption, but that power consumption is still going to be the same eventually if we do not get a total reduction or a change in the way that we use the power. Reuse is an interesting one because I'll touch on that later. It's in its simplistic terms. If you're looking at reusing a bit of a building at the moment, it's as a result of a building being knocked down. You're looking at transferring one problem to another problem. Where we're using reuse, the current frame conversation is around reusing one product and repurposing it for another lesser quality use product in the same project. So it might be using a redundant pavement and then using it as a sub-base material for the new pavement. So it's still downcycling, as they refer to it, but it's finding a way to still use that material on site. And then recycling itself, historically our terms of recycling is grabbing the materials that were once a virgin material for the manufacturing of a bottle or so, and then that gets mixed up with other plastics, and as a result that recycling of that product becomes a lesser quality as a secondary product. There's an interesting term around rebound effects when it comes to eco-efficiency. So if I use that example there of the LED lights, we replaced all our metal halogen and other lights to LED, and human nature has a tend to think as a way of thinking now as a result of having these LED lights that they're more efficient. We tend to leave them on longer as a result. So tests have shown that human nature will react in a way saying, well, it's using less than it used to use, but still not really using it for its full potential. So we're not getting that full efficiency. So there is that rebound effect. And overall, the eco-efficiency is aimed at less harmful rather than being 100% helpful. And just bring that back in more. I know efficiency itself has no independent value. It depends on the larger value of the system of which it is a greater part of. So it's not something to put a value on the efficiency because it relies on everything else as the greater part. What we're trying to move towards now is an eco-effective approach. So stepping away from that linear approach and looking at more of a cyclical process where we are looking at a holistic approach. So it's focusing on the right products, services, and systems which will help the world and the planet that we live in. So trying to move away from that linear one-use products and trying to find how we do it. Don't controlling the nature we're in, but work with it. So a prime example is the roofs that we generate, or the roofs of our houses obviously generate a lot of runoff. They generate a lot of heat. So the more we build, the more roofs we've got. In an environment that didn't have roofs previously, we're now creating all this extra runoff, all this extra heat. Flipping that conversation around, actually turning the roof into a green aspect where you can actually retain some of that runoff, reduce that heat, and actually working with the nature so you're not going against what its natural form was. So it's taking that train of thought and applying it to whatever it might be, whether it be a field of play, whether it be a building, trying to think how we can return it as close back to nature in its natural form. So again, supporting that relationship with the ecological systems, removing that what's meant to be one-way linear flow of materials, and develop a positive relationship between ecological and economic systems. So at the moment, the one-way system is a negative relationship. We create waste, it goes into landfill gets bigger, and that is a negative impact on not only the ecological but also the economic system. So if we can find ways that those products can be reused back into a system, either be in that system that project's being built there or another project, we can not only avoid landfills, but it creates a positive relationship. And this is really aimed at materials to maintain their status as a resource in the future. And I'll talk on that in the future, later in the presentation, but it's a critical bit there that the resources we're using maintain their form, their structure, their properties, so that we can reuse them as either similar or a different byproduct. This is a quote that came out of a great book. If you haven't read it, The Cradle to Cradle, and making the way we make things, but it's around looking at things and consuming products that have nutrition for our nature and in our industry. And it's a really interesting term, the nutrition, whether it's biological nutrition or an industrial nutrition. It's looking at everything we put into what we do, having something for either going back to a biological breakdown or being put back into industrial as a good. So again, it's creating that relationship between what we build now and the environment in the future. So that nutrient conversation is really critical. So there's a couple of things, a couple of approaches that I'll talk on today, but they all have the same underlying principle, which is around doing good. So it's a life cycle assessment, so looking at each individual item and understanding its life cycle. The cradle to cradle, so rather than that cradle to grave where the element ends up in the landfill, looking at a cycle where it can be put back into another product or another system, which again leads to the circular economy. Some people separate those two words, some people liken them as the same. And there's a really interesting research paper that was done a couple of years ago around buildings in particular as a materials banks. So looking at, I think it was in Holland or Denmark, they did a study around designing buildings now that could be resource banks for the future. So knowing everything has a design life, but at that end of that design life, every element was identified for a reuse in another form of construction. So they actually identified those elements, broke them down individually, and specified for when that time came what the material could be used for. So life cycle assessment, we're all very familiar with that, assessing the impacts with all stages of the product's life. So looking from go to woe and seeing what the life cycle assessment is. It doesn't put any burden on another element. So what I mean by that, it was best explained, I read, was around cucumbers in our supermarkets that are wrapped in plastic. A lot of people say, why are they wrapped in plastic? So they did a life cycle assessment on it being wrapped in plastic and not wrapped in plastic, and the amount of spoil and damage to the cucumber as a result of not being in plastic was more, all the effort to grow it, all the resources used to grow it, and end up being spoiled before anyone can get to it, versus wrapping it and a high percentage of that making it to the consumer, and the byproduct being soft plastic, which can be recycled if put in the right hands. So it was actually doing the life cycle assessment on that cucumber, wrapped versus unwrapped. It was found that actually being wrapped was a better environmental outcome to the society. So that's one approach, is looking at individual components and breaking down the life cycle assessment of those. I guess the most common one and at the front of everyone's mind at the moment is cradle to cradle or circular economy. It's looking at that, completing that whole circle, so that everything that starts off as an element ends up being put back in as an element as another one. So this was talking about the biological and technical cycle. You can see they both, if you start at the top of production, they both end up as a nutrient of some sort. And the term, biological nutrient is easy to explain because it breaks down and might become a earth or a soil or a nutrient back into the growth in that plant, and then that grows back into a cycle of a product. But a technical nutrient is something that is man-made or man-created that doesn't lose its ability or quality through the cycle. So it might be a stone as an example, or a plastic that can be readily separated but can still sustain and maintain its properties throughout the life. So again, looking at that cycle, what we put in the ground, can it be reused at the back? And from a field of play perspective, almost 90% of what we do can be recycled or reused in another frame or mode. This is the issues that we have around the moment is around the finishing surfaces on some of them, be it the running track rubber or the synthetic grass. At the moment, we don't have the technology or the manufacturing locally to turn that into a circular economy. As I said, this is the building as a materials bank. So each individual component from one building that they were designing, they were creating what they would call material passports that could be then reused in another. So a building has a design life of 50 years. Every element within that building would have its own identification ID, and there was a subsequent specification post-construction of what that material could be used in a disassembled space. So again, looking at our projects as not just a built form that eventually gets thrown out, but looking at it as a built form that eventually can be salvaged, reused in either a similar construction or something similar. So now I'll just talk on a couple of things of what we can do, and really this is just an entree to conversations, hopefully at the back end of the presentation, with us all can participate in. I guess for mine, it's getting the project fundamentals right at the start. You know, from a field of play perspective, know the site, what you're putting in there. Does it need to be built? Does it meet this terrain? Is it the right surface type for that area? Develop a brief for the future, not for the now. So again, you know, often we put in particular around synthetic grass perspectives, we put in components to the synthetic grass that may be right for the now, and generally that's right for the now's budget, but for the 7 years down the track, the materials that we're putting in now, we know are not going to be right for the future. So again, it might be a little bit more upfront capital, but in the future, it creates that circular economy. Do it right. It's like everything. If you do it right, the first time it's always cheaper that way around than having to come back and rectify it. And make everyone accountable. There tends to be, I find, a job gets built, and you know the poor curator, I was going to say poor, but the curator is lumped with an element that may not be fundamentally correct. On a poor irrigation, poor drainage, and there's never any accountability to the fact of that. So the maintenance crew are stuck with something for 10 years until that next field gets rebuilt. So we really need to keep ourselves as designers, contractors, everyone accountable for the works they're undertaking. Transport's a big one, and it's a very hard one to, at the current council criteria, to mitigate, but it does make up 18% of Australia's annual greenhouse gases. That figure changes probably with COVID. It is the second largest emitter of CO2 annually across the world. It also has the highest emission growth, even with all the implementation of smart electric vehicles and hybrids. It still has the highest emission growth. What we can start trying to implement is sourcing local products. So whether that is local to the region or local to the country, or you know, we're transporting materials from interstate, we're transporting materials from overseas, either in a built form or individually. Are there ways that we can weight the criteria within a council assessment paper that, you know, it does promote the use of local products? I know often there is a small percentage of that in the assessment, but you know, can we look at increasing that in that weighting? And you know, reducing waste and reusing site materials obviously reduces less transport, and I'll talk to that as well. Alternatives to carbon intensive materials. So look at substituting out high carbon materials. You know, the highest of all of them is cement, as a result of the Portland cement in there. In our concrete, I see too many projects have excessive amount of concrete in there for not much gain. Concrete's the biggest bugbearer. When it comes to carbon, you've got the steel work in it, you've got the carbon itself. There's a lot of carbon embodied in there. So do you need that extent of carbon, that concrete? Can you minimise it? Is there an alternative? The more times we use alternatives, the better those products become and more affordable they become. Steel and plastic obviously are the other 2 and 3 highest carbon intensive materials. I said, looking at alternatives even. So, you know, if you've got a trench grate concrete, a trench grate which requires a concrete surrounding in it, can you get away with something a little bit more natural, a little more less? You've got 2 products in there that have carbon. Can you move away from that? And I'll talk through some examples around synthetic grass, around how we can move away from certain components that have high carbon intensive materials in it as well. And do you actually need that element? You know, we've started looking at our designs and really trying to strip them down to see if every component that we put into our designs is needed. Do we need that much of extensive drainage through a natural turf field? Do we need drainage infrastructure around the perimeter if the infield is draining at high intensity? So we're looking at really, do we need those elements? I've done a little bit of work with the carbon footprint company who've done some assessments of our designs to understand the embedded carbon in it, and a great phrase they told me was carbon follows the money. So if you're looking at 2 options, whether it be a trench grate and a concrete spoon drain, that trench grate is wrapped in concrete, and the concrete spoon drain is less effective, less aesthetically appealing, but the trench grate costs more and subsequently has higher carbon with the fact that it's got the trench grate and the concrete surround. So generally speaking, when you're looking at 2 alternatives or looking at 2 options, the more expensive one generally has a higher carbon embedded component in it. This one's probably really self-explanatory: zero disposal and zero waste. So if we can keep it on site and we can have effective designs, we can minimise our zero waste. So understand what we've got on site. Can we keep it? Can we treat it? Can we use it in viewing mounds? Can we just remove the need to dispose it off site? Sometimes sites don't have the space to allow that, but if we can investigate and try to look at every way to keep that material on site, whether it be in a main role or a secondary role, if we can keep it on site, just removes the waste being generated going to landfill and the transport to get there. Effective designs, so if we can get as much out of our designs that minimise waste at the end of the day, it would be a great outcome. And I've challenged some construction contractors along the way to really minimise their waste disposal. Try to reuse as much as their concrete formwork rather than having significant formwork and having redundant formwork they end up having to throw away. So really challenging them to see if they can minimise the amount of bins of waste that they take off site. Recycled materials. I like this image. No one's got their microphone on, but I challenge a lot of people to try to tell me which one's the recycled concrete and which one's is just a straight crushed rock. It's looking at the reusing material. So often when we talk about rock as a reuse component, it generally has to be a substandard to what it was originally. The quality does diminish ever so slightly. If you probably were to test it, you'd probably get away with a class 2 rock becoming a class 2 rock in a new build, but it requires the material all being tested and taken off site. So the easiest way is just to diminish the quality of it. So a class 2 rock might become a class 3. A class 3 rock might become a nondescript crushed rock, and same with concrete, crushing up your concrete and reusing it in the pavement. So there's plenty of examples, and I've come to one at the end of a great example of council recently using a lot of recycled materials throughout their build. You've got crushed concrete, you can reuse your crushed rock, recycled glass, growing medium itself. You can harvest the growing medium, either reuse it in the field if it's suitable, or reuse it in the growing viewing mounds, and a lot of crushed brick as well. I guess this is probably encapsulating everything. Really, it's just planning for the end of life. And if we can create that cradle to cradle circular economy, that image there shows, that helps to minimise the waste. There's always going to probably be a little bit of waste product. We're never going to 100% remove that, but if we can find ways to continually create that cycle, and this is that phrase of nutrient, and I said that technical nutrient is an inorganic or synthetic material designed to be retrieved and reused without loss of quality. So that crushed rock, in theory, can be that component. It could be reused, but ideally, if we can plan for everything we put into our designs that can be reused at the back end, whether it be put back in as a subsequent or a main element, we can help to reduce the waste and the carbon creation. Moving forward, now as designers, we're going to challenge the status quo. And if a client comes to us and say we want to get as carbon neutral as possible, there's going to be things that we're going to do that is, may not have been readily done before. And there's going to be cases that sometimes it's going to fail. I know when we started first using crushed concrete in our pavements in different areas, we started getting reflective cracking. So we had to find ways to combat that. And we wouldn't have found that out unless we started trialing it. So if we do go down this path to start making this commitment, back the cause, we're going to have a couple of misses along the way as an industry, but we need to find what works and what doesn't work. So we just keep doing the same, we're not going to get there. A couple of case studies, ranging from this one here, which is the only carbon negative country in the world, in Bhutan. It does help when the country is covered in 70% of trees, but it really highlights the fact that if we need to get to this carbon neutral net zero for our projects, it's a lot of trees. This is the only carbon negative, and admittedly, they've really embraced it. They've given free hydroelectricity to their farmers, to their housing as a result of the rivers. They've got a strong partnership. They've developed a partnership in recent years with Nissan to provide the country with affordable electric cars. So they're really embracing this fact. It's probably not as industrial driven as other parts of the world, and they've got their kings of Bhutan to really thank to that. They've created that gross national happiness index, which the fourth king of Bhutan said it was more important than gross domestic product. So they're really living by that, and that's a completely different train of thought than what we're used to. We live in a materialistic world. They live in a world where they live within nature. So again, this is a way out there example, but it really shows how far you've got to go if you want to do it working with nature. A study we've done recently was looking at the embedded carbon in our tennis courts or netball courts. We had 2 designs analysed by a carbon footprint company, a concrete base and an asphalt base, and looked at the embedded carbon through that. So what we do from a field of play perspective, there's not a lot of moving parts. So if you look at the life cycle assessment flow chart down there, we're only operating in 2 of the first 2 stages, product stage and construction stage. Our usage stage in the field of play is there's no moving parts, there's no air conditioning, there's no heating, there's no elements that require ongoing servicing. Yes, there's some maintenance, but it's very, very minimal in compared to a building. So our analysis is really easy in regards to its upfront, and then if and when we move into the afterlife analysis, that we can start looking at. But for the sake of this investigation, we just looked at the upfront design and construction phase. It wasn't surprising really to look at rigid pavement, and there's an alternative, and then flexible pavement, which is the asphalt, and then an alternative. So if you compare the rigid pavement and the flexible pavement, which is the first and third column, you can see that the flexible pavement has a 38% reduction in CO2 emissions through its construction. And you can see those colour coding, significant variance in that is around the concrete. So our traditional concrete methods with the Portland cement has a significant embedded carbon into it. So what the alternative shows is if we can replace components of that concrete that help reduce it, but at the moment those additives or replacements, the quality and the cost are a bit prohibitive at the moment. So it shows we can do that, but again, as I was saying before, if we're going to commit to the cause and we want to go with concrete pavements, we need to start trying these alternatives to get that embodied carbon down. I guess this is a history of synthetic grass that we've been designing, and it probably also shows the history of our drafting along the way. But the first design was something we did when we first started off 7 years ago, and it was a synthetic synthetic pitch down at Geelong University, University of Deakin down at Deakin University down at Geelong's Warren Ponds campus. So a synthetic pitch. It was probably one of the very last at the back end of construction, where it was all built on a completely compacted crushed rock pavement. And then the train of thought back then was you trench your subsoil pipe through there. Moving across to the next evolution, we started removing the trench pipe work and putting in the drainage cell. So already that inclusion of the drainage cell, that itself is a plastic component that has a high carbon embedded component to it. That also requires something to capture it at the drainage. So at the moment we design that to have a trench grate at the edge. So again, another element that has a high embedded carbon. We've since moved away from that type of construction and into more of a free draining aggregate base. So all automatically that bottom right image you can see hasn't got the drainage cell, and it's just a natural free draining aggregate that has a shaped subsoil that's subgrade that drains to a piped outlet. So again, we're removing significant amount of carbon embodied material, and we started looking at that free draining aggregate itself being a recycled crushed rock and other recycled concrete as well. To again look at the use of recycled materials. And then the next evolution that the industry is now looking at is the synthetic grass. There is an infill-free system, so it's got no rubber, just sand. It's been specified for a high-profile site in Sydney. It won't get the FIFA requirements. It'll meet most of them, but it won't be FIFA certified. But again, we're moving a component out of the profile, being the rubber performance layer, that had the natives restless around the microplastic displacement, but also just removes another product out of the design. So again, just showing the natural evolution of what is at times a product that can get people's noses out of joint. This is a great example. I think I saw Brent Gordon here on the line as well, who was responsible for the design down at Darebin City Council. So KP Hardeman Reserve, as you can see from their post there, fantastic initiatives there where they use recycled brick and concrete, 95% of recycled crumb tire for the shock bed. That's been used like that for years. Everything else, recycled glass and conduit, backfilling, recycled soft plastic. It's tick, 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 tick. Fantastic initiatives. The one thing that I did pull out, and at the moment the industry doesn't have a response for it, is actual repurposing of the existing synthetic grass. You've got over 8,000 square metres of synthetic grass that could end up being chopped up into multiple areas that gets sent off to multiple different locations. The microplastic control is is uncontrolled, you're handing over a product that's already deteriorating, and you're going to get uncontrolled disposal. So in that instance, it's actually probably better to put it in a landfill because it's going to get there rather than contaminating the environment. So there's everything we look at. There's always going to be two sides to the equation, but I think this is a great example of committing to the cause. All those ticks, the bricks, the recycled products, everything. It's a fantastic example. So it's a great case study. But this still doesn't get us to zero. We do all this, we're skinny up everything, but we've still got carbon in everything we're doing. So how are we going to get to carbon neutral? There's not a lot we can do around the room. We can tighten up our designs, see if we can look at everything we can to try to minimise that and look at the holistic approach. But we're still, through the sheer fact that we've got transport and construction activities, there is carbon created. So in a bigger picture, it's all about carbon sequestration and offset carbon credits. So through all the carbon that is created through our designs, our clients or yourselves, depending if you're other clients, can look at offsetting those carbons through green initiatives that others are doing. So it might be, there's lots of rewilding of areas, so reforestations of what might have been forest at one stage, was all chopped down to be created as an agricultural area. It is now being reforested or rewilded. So those trees, those landowners can, through the Australian government, receive credits for that. So obviously the trees themselves are absorbing the CO2 in the atmosphere. So that can be a credit that can then be passed on to someone to offset it. So it becomes an actual bit of a subsequent coverage for something else, whether it'd be more efficient agricultural processes, solar paneling, all these type of things. So there are ways to offset that to get it down to zero. So that in itself creates another path of investment that obviously will have to be driven by governments. And this is just a very crude representation of those. So this is going back to our pavement design that we did and had analysed. So the rigid pavement is our concrete. The original alternative was the reduction in the concrete components. Flexible has been the asphalt and then alternatives, but it shows if we wanted to offset my rigid pavement, I would need 12,500 square metres of solar panels to offset that design, or 10 hectares of forest, or $40,000 worth of tree saplings to be planted, or I can purchase some Australian carbon credit units, which would in this case be approximately $6,000. So shows you how we can get to zero once we've done what we can do. So as designers and as clients, we can only go so far with our designs and our construction. Ultimately, there is going to be a last bit of carbon there to get us to zero. These are the way that at the moment the industry is lining up that we can achieve that. So thank you very much. That's really where we're finishing up there. I said it was hopefully it's a bit of food for thought. I've seen a couple of questions that have come through from the chat. There's one from James. Thanks, James. Great talk. I understand the temperature above synthetic is much greater than natural. What is the overall carbon balance of having natural? But yeah, that's a very good question. And I will have a response directly to that, James, in the coming months. We're having our synthetic design, our different infills and different synthetic products being analysed to understand the carbon of the different infills and the different systems. And then we've just had our natural turf ones to analyse, so we'll be able to combine that. But obviously the processes are significantly different, and I would imagine the synthetic grass itself would have a significantly high embedded carbon as a result of the construction.
Jared, Richard here. Great presentation. I've just got a question. Do the opportunities for the reuse and recycle need to occur at the planning and the design phase, or can the tender process call for innovation and put some responsibility on contractors to look at the site and the plans and try to identify some opportunities themselves? What, in your experience, what do you think works the best, or is there a combination for both there?
To be honest, a lot of what we're seeing is being driven by contractors themselves. Historically, designers are always risk adverse. So if I use the crushed concrete as an example, I was always adverse to it because there was too many examples I was seeing of reflective cracking coming through the pavement. So you've got all your cement element there, so it becomes semi-rigid, but then it cracks and you get that reflective. So it was the contractors themselves that brought that initiative to the table, and as a result of using it more frequently, the cost for that product actually has come down and is cheaper than using virgin materials. So they've driven a lot of that. I think now seeing how that process, just with the rock example, is that's that leap of faith that they took. They had to sign off on it. I think moving forward, we need to look at that through all elements of the project now in the planning phase of saying, okay, that's what we've seen work with rock. What can we do with different components, whether it be the concrete and using different additives in it rather than Portland cement? That, the first couple we might get the mixes wrong and it might crack a little bit more frequently, but we need to work out, how we can plan for it now, knowing that it has worked with different components already.
So potentially a learning there, Jared, for LGAs through that tender process to try to be really bold in the tender documentation to encourage companies to be innovative, and that cost isn't necessarily then going to be an issue as part of that assessment process as well.
It's a difficult one because, I said, designers by our makeup is we are risk adverse. So we see a lot of products come along the way and we can see flaws in them, so we don't see them. So often we see a good product and we're hesitant, and we take the safe option out. So it's as an industry, we need to embrace these things and work together to share that knowledge about what has worked, what hasn't worked, so we can fast track those learnings as well.
Yep. Anyone else got any questions or comments? I see there's one there from Lucas.
Yeah, so that's a very good question, Lucas. I think I've seen a lot of states. I was reading the New South Wales commitment to the 2050 target, so it ends up putting the pressure down the line. So if you don't have the federal government dictating it, it then becomes something that the individual states, and I'm now seeing councils like City of Melbourne, City of Sydney, City of Adelaide are now committing to these things. So I think whether the federal government gets behind it or not, if anything, will probably slow the process down. So it's going to take a lot of commitment from those underneath them to try to put the pressure on it to make it happen. But I think that the great thing is what we're seeing is there's lots of companies out there who are taking on board themselves. There's some fantastic, as I keep coming back to crushed rock, but there's a lot of great quarries that are now realising they can't keep digging holes and making rock. So they're finding alternative processes to process that old material, and they're taking that material on for free, saying, well, give it to us, we'll get rid of it for you and we'll turn it into something, just dump it here for free and we'll turn it into a product rather than paying expensive dumping fees.
Jared, I'm interested, Richard here again, I'm interested also whether or not, is there some sort of central repository of knowledge that councils or contractors that I guess have implemented some great projects that do result in a reduced carbon footprint? Is there somewhere or some organisation that can track this or can receive information about these examples, or is that still a bit of a void in the whole?
I mean, with my limited experience into it, I'd say it's a void locally at least. As I said, the UNFCCC, they have, if you look at their annual reports, they post every 5 years. They do have links to different components. Like everything, the European region is miles ahead of everyone. The Denmarks, the Hollands, all those type of worlds that, some of them, like we were at one stage aiming for zero by 2050. We've got some countries that are trying to do it by 2030. I think Sweden are trying to get net zero carbon by year 2030. So, they're the type of countries we need to read from and learn from.
Yeah.
I've got a question. Great presentation, Jared. And just following on from what Richard was saying, that last slide you had comparing carbon offsets and the effect on the design. Perhaps that's something that we should be trying to push for local governments to have some sort of assessment in their design stage about the options they are presenting and the cost or the possible savings they can make by, example, minimal removal of material, minimal drainage inclusion, repurposing, irrigation, those sorts of things.
Yeah, I think you're right. I mean, I think where we're going to get to as designers is we're going to have to show clients not only the monetary value of the cost to build it, but also the carbon component to that element. So here's a cost for your concrete component, and here's the likely carbon embedded in that. And give them alternatives that have a dollar value of it. And hopefully we end up not having that conversation about dollars, and it's simply a conversation around carbon, and that becomes a decision point. Great question from Heath there on there is around maintenance. What we're doing from a field of play perspective at a design level, it hasn't been done before. So I went to the carbon footprint company with this 6 months ago, and all the carbon footprint analysis, the ISCAs, the Green Star, all that is for much larger infrastructure, for your big tunnel projects, your highways, your buildings. They don't have a tool that allows you to get down to the microscopic size of the projects that we're looking at. Working with the company we're working with, they had to sort of almost create something on the basis of the information they had around that. So moving into the maintenance perspective, no, the simple answer, they don't have, and it's something we probably will be the next stage, moving from design to understand what the maintenance associated with it, because they'll start strengthening conversation around maintenance of natural versus maintenance of synthetic and those type of things. So I'd like to think that's the next evolution of the conversation.
Jared, I might, if Heath is happy to come online. Heath, is there anything that you or your team are doing at the moment with your maintenance that you think might be innovative or interesting for people on the chat today to understand what you're doing?
No, not really, Richard. I guess I'm excited by this this presentation to sort of kick the ball rolling, kick the ball down the road, if you like, for us. I don't think we've got anything. I think the key thing for us is we've got a commitment from the council that they want to, get to a carbon neutrality by 2030. Now we've just got to find a way to get there. So I think that's the start for us, is to understand how we can get there. But I'd be really happy to have a chat with you offline, Jared, or work out how we can, flesh out some of these ideas, because I think what you've talked about from a project perspective, and I've been involved in some of the ISCA tools previously for projects. From a maintenance perspective, I haven't seen anything or across anything. So
yeah, I mean, from a maintenance perspective on the ISCA, it's all more about the mechanical components around the ventilating, the heating, the cooling of buildings or tunnels and the like. So it would be a completely new rating tool that they'd have to sort of look into. So it's definitely something that could be considered further.
Yeah, I was just saying, if has anyone else got anything that they'd like to add or contribute? Otherwise, we can conclude. Sing out if you've got something. No? Okay, we might just wrap up then. Look, we had just over 30 people in today, Jared, and I think from what I've heard from you, and also some of the interest in some of the questions and statements that followed, there's clearly a conversation that needs to be continued here. And I think I'll take that back to our board, Jared, and you can as well, given you're a board member, and to see how PLA can continue to provide opportunities like this to its members, probably on a regular basis, and champion some of the projects, such as that KP Hardeman Reserve project. I mean, if there's projects that do come up like that tick a lot of boxes, well, let's share that story in a way that can get to as many people as possible. So thanks again, Jared, and all participants this morning. Some fantastic learnings and sharing of information. I'd like to acknowledge and thank all of the VicTas region sponsors. Jared's company, Sport Energy, is one of those sponsors. Christie, Lark Industries, Syngenta, Glasgow Landscape and Civil, Playground 123, and also the Victorian State Government. And of course, our industry talk sponsor, ETP Turf, today. Just reminding people that the session was recorded. That'll be uploaded onto the website and be available in a matter of hours if you think that you'd like to pass that recording onto colleagues or other people that you share your work with. Jared, if you've got nothing more to say, I might say then the formal goodbye. Stay safe, everyone, and have a great day, and look forward to catching up in the future.
All right. Thanks all.